Welcome everyone to this webinar about applied NLP. Today I'll be interviewing Paul Verhaar. He's a lead data scientist for Sogeti in the Netherlands. He has a passion for innovation and NLP. He loves complex problems that require creative solutions. So I'm really looking forward to our interview today.
Thanks, Jolene.
So we will start with 2 questions for our audience in Mentimeter. For the audience, you can go to menti.com and enter the code above. So the code is 241715, and you will be asked to answer a question for us. Our first question is about BERT, actually.
Curious to see what people come up with.
Very curious, especially since you haven't explained them anything about NLP yet.
No, really cold start in the afternoon. Love it.
We have a lot of players here.
Yes.
See what they come up with. So we all know Sesame Street. That's good because I think that's an important part of your education. But we also have 11 people that said it's a language model, and that may come a bit closer already. So to take one step further, we have another question as well. That's about what is NLP, and that's where it's getting serious, I think. So the audience can go back to menti.com and answer our second question.
Somebody's really fast. Nice.
Yeah. So this is the question, what does NLP mean? Neuro-linguistic programming, which a lot of people I think know also. Is it natural language processing? Maybe a band name or an organization? Okay, so I think we're in the right corner here for natural language processing, and a lot of our audience had this right. So Paul, could you explain to us what it exactly is?
Yeah, sure. I'm actually, first of all, happy that the other people knew the other thing as well. I don't know anything about that. So there's a question about the programming part. Don't ask me. So the thing we're going to talk about today, the natural language processing, is part of the data science discipline. I'm basically the sort of old school guy that studied linguistics before it became computational linguistics, before it became NLP. Basically meaning everything text. So we're focused on getting representation, knowledge, meaning from any piece of text, which is super interesting because we have tons and tons of unstructured text, and that gets more every day. So it isn't within the field of data science. We leverage stuff within the AI field, machine learning, deep learning field, whatever you want to call it. And the machine learning, deep learning part refers to the sort of techniques we use. For the people that are paying attention to the graph closely, you also see speech to text and text to speech, which is definitely a part of NLP, but not for today. I might mention a couple of small examples, but my main focus is going to be within the NLP realm on text data. So.
Okay, so this gives a clear image also where NLP is in the space of artificial intelligence. And then for day-to-day applications, I understood that there's already a lot of applications that we all use in daily life, but might not know. Do you have a couple of examples of that?
Definitely. So that's the cool thing, I believe. That's also the reason why I got into the NLP field. For starters, there is some sort of magic connection between the things we use in everyday life, the alphabet, words. We actually use a finite set. So our alphabet is a finite set from A to Z. But we can come up with new words every day, even if we want to. And that's the thing that basically got me into the field. And if you expand that, we can do a ton of stuff. So whatever what you see here within the NLP bubble, and the NLU bubble are all techniques we can use. So, for example, named entity recognition, which I will give an example in a bit. Syntactic parsing, really important. Machine translation, instantly an example of what we might use on a daily basis. For example, if you're taking up a new language course, you don't use the old-fashioned dictionary, but you go to Google Translate, which is hardcore NLP stuff. The NLU stuff is embedded within NLP, and basically stands for natural language understanding. So really extracting the knowledge and the meaning from the text and creating the right representations for that. That's also why there's a difference between syntactic parsing and semantic parsing, two very important building blocks for language. Semantics basically means what do you mean with the sentence. Syntax is how is the sentence formed, so the structure. If anybody has seen that before, it's like this weird tree structure that goes down and down and down, and in the end you have the entire sentence dissected. What you see in the bottom right is an example of that. So we have entities, and with an entity I mean, for example, a company like Apple, that can be recognized within a sentence. That's also actually pretty hard in some cases and has to be derived. So we're getting pretty good at that, because an apple can still be a fruit next to a company. We can find sentiment within reviews, for example, so Airbnb reviews, product reviews. You have the spelling correction on your phone, on your laptop. Basically really big things we use in everyday life. Other things we use, and that's the little sidestep to the speech domain. You can basically tell Siri to play Bohemian Rhapsody, for example, and it'll do it, which is natural language understanding and speech to text, and the entire engine behind it that parses the semantics, the syntax, etc. Other things are, for example, if you go to a product page where you want to order a red dress, by now you can fill in I want to order a red dress. And the search results are going to give back a red dress. The same goes for Google, which we use in a ton of cases, and question and answering things. So not only in the realm of chatbots, but other applications really focused on the text, which is something we do within Sogeti as well. So that's basically the cherry on the cake. And the thing that is becoming more common is language generation, where we basically give a text and then the algorithm finishes the text for us or gives us new text. So a ton of applications.
Interesting. And then you always say this is so complex, but for a human it comes natural, so it seems easy. So I wonder, do you want to come across as very intelligent, or is it really actually that complex? And could you explain to us why it's that complex for a machine to do?
Yes. So there's a couple of classics, basically. So you can even reuse classics from university. But these things are actually headlines. So if you quickly read through them, it's actually perfectly fine. You'd read them like any newspaper headline. You'd be like, okay, I understand what's going on. We are really good at deriving meaning from text. We can even finish each other's sentences, and in a conversation, we can tell people like, oh, I think you mean this or that. That is what makes humans really intellectual in that sense and capable of deriving language. So for example, a couple of headlines that are in the slide. So scientists examine whales from space, it's really ambiguous in a sense, right? Where do the whales come from? What is the exact meaning of the sentence? It could even be clickbait by the looks of the headline, for example. So it's really hard for a computer or an algorithm to figure out what's going on. And one of the building blocks I mentioned, like syntax, for example, is really important in this sense, because if you parse that tree wrongly, you get a different meaning. So let's take the second one as an example. Girl hit by car in hospital. So the girl gets hit by a car, and the headline obviously means in our sense that the girl is now in a hospital, but you could also read it as the girl is in a hospital and hit by a car within that hospital. For us, it's pretty clear again. But if you give this to a NLP algorithm language model, it's going to have a hard time figuring out what it exactly means. So I find this really interesting. It's something that we do by nature, happens everywhere, and well, NLP is just trying to solve that so we can have the computer solve that as well. In that sense as well, we're pretty good at doing this quickly, obviously, especially if it's just a couple of headlines. The really painstaking moment comes in if we try to do this on a larger scale, and that's where we basically need the NLP algorithms. We need the computers to help us out, and if we have a computer understanding this stuff, yeah, we can achieve human-like behavior. The other classic example is something I really like when Siri came out, which is actually a pretty serious message, but it's completely misunderstood. So yeah, I wouldn't trust it that much. Of course, we're making progress, but yeah. So that's why NLP is hard. It's really hard to derive the meaning of the text. And what we'll see later on as well, especially also in generation, it's really hard to derive the context in a meaningful sense. So we have common knowledge of the world, etc. Another really interesting example is, for example, if we think of a sheep is white in our sense, and we have sayings that contains a black sheep. So if you train a simple algorithm, it's gonna instantly recognize sheep as black, for example. On the other hand, if you have just text that contains sheep, and you ask the algorithm, for example, in a Q&A setting, what the color of a sheep is, you're not going to get an answer. So that's stuff that we're missing, and that's why NLP is really hard.
Okay, no, I got it now. I got it. And then Siri, we've known for a while, and sometimes my Siri goes on accidentally, and then I tell it to shut up, and it does actually. It leaves. But I'm wondering, how did it develop over time, and has it been there for a long time already? And what's the development, and what trends do you recognize in NLP?
There's a ton. It's a big question. So it actually goes well in the 50s. It became interesting, and well, basically a small side path, and everything we use nowadays, from deep learning architectures, algorithms, ideas that actually come to life now, are already developed or founded between the 50s and, let's say, the millennium. So there are already a ton of smart people. Not saying there are, well, less smart people now, but back in the day, they were already pretty keen on developing this stuff. For example, a couple of the algorithms we use every day within the NLP field came from the idea from the 50s. So basically what we were missing back then, computational power, knowledge on how to represent neural networks, actually have all that data coming in, and especially all that data was missing because we didn't have the internet yet. So back in the day, we had linguistic knowledge, and that was pretty prevalent when I was studying linguistics still, because that was approximately 7 years ago, and we were still doing corpus linguistics on small batches of a corpus, not even taking into account, for example, Twitter or Facebook posts, and we were creating linguistic rules. So that was still being taught in university compared to Silicon Valley stuff, advancing and advancing. Right now, as I like to frame it, my linguistics master doesn't mean that much anymore. Because if you know stuff about deep learning and you're interested in NLP, you can solve that problem just as well without knowing stuff about syntax, for example. And well, the combination is where it gets really interesting, and that's where we're at now, because you have to be able to infer or derive what the models are doing, if they are creating the right content, if they're classifying the documents in a good manner, that kind of stuff. But there's this turnaround point, especially around the statistical models, where we had statistics, rules, and we can see something comparable with the early chatbots, which are all rule-based, and they're slowly moving into AI chatbots. But the beginning was basically linguistic knowledge, rules, and code. And now, after the 2010 kind of thing in the graph, we have the giants coming up. OpenAI has been founded by Elon Musk. Google is really on its best game. Microsoft has done cool stuff. We have also a good example of the IBM, the Watson example, where it beats the game show by actually nailing the questions and earning the most money. And that's the sort of shift where machine learning comes in, and especially deep learning now. And yeah, it's really interesting. We're having a big moment.
Okay, so it hasn't been a smooth process, I think, and it is accelerating at the moment. And I heard about this Google breakthrough. What exactly is that?
Yeah, so that's a bit older, to be honest, but it's still usable. Oh, yes, there it is. So it basically ties in with the 1950s argument I mentioned. There's a really famous quote by Firth, basically saying, if you know a word within a sentence, you know what the word is. And that is something that we can do really well. We can derive meaning from a sentence, words, and then I can tell you, for example, okay, now you know this word, make a new sentence. And that's why we humans are so good at NLP stuff. But this basic idea is what Google developed. And if we take a look at the left side, so the image above, bag of words, which is basically nothing more than a bag full of words. So you input a sentence, and that sentence is being dissected word by word. So a really simple trick would be, you have a sentence, you see a white space, and outside the white space is a word. So for example, what is a word? Is this a word? Behind is a word. And as you can see, what's happening is basically tallying. So what gets a 1, because that is a word in the sentence, all the other words get a 0. And you end up with a gigantic matrix, or a really big Excel sheet containing a ton of zeros and a couple of 1s if that word is present in the sentence or in that place. So that's basically a really big bag of words you can shuffle around, and that was the beginning. And Google used this for a really long time to display search results. Then they developed something else, which is the word-to-vec stuff. Basically making sure that we can do math with the words itself. And it basically works on the quote above, saying that if we have words in a similar space or in a similar manner in a sentence, then they must cluster together. For example, if you have a ton of words containing, I don't know, Starbucks, bagels and beans, any chain that is connected to that, they will end up in a similar cluster of words, which means that you can also use that in a math setting. So if we take a look at the right picture, you have king plus man, for example. So a king is male, it's a male noun. But if we subtract man and we add woman, you get queen, which in our case makes sense. But the cool thing about this, and that's why it also was a breakthrough, next to clustering these things, because the space where all the words end up, which is basically a big ball of words in the end, you can see that you can do the math setting with this, and that man and woman are closely tied together. So for example, the word dog would be somewhere completely different in the bubble. The same thing we can do with verbs. So it's really easy to detect the present tense, past tense, for example, and it can also give you back, okay, well, we can do similarity measures between words. We can do connections with words, and we can see if, for example, new words are emerging, which is something that's been done pretty well in marketing. finding out trends, etc. So that's the big breakthrough from Google.
That's really interesting. And also it was 2013, I believe. So that was when you were still studying.
Yeah, sort of.
You just mentioned. Yeah.
Yeah, sort of. Yeah.
And are there any more recent breakthroughs in NLP?
Yes. And that's where, well, at least for me, it gets really interesting. This by far is already interesting. And as a side note, what we're using today is still word effect. So, and in some cases, if we have really little data available and a sort of simple problem, we would still use a bag of words. So we don't necessarily need to use all the state-of-the-art stuff, but that is becoming available is even more cool. So why am I using these pictures? So I haven't founded the names, of course, but it's referred to as the Sesame Street because we have Bert, we have Ernie, we've got Elmo, and they're all really nice acronyms for something that we call the more recent breakthrough, or referred to as the Imagenet Moment for NLP. So for those that don't know what the Imagenet Moment is, that was within the image recognition spectrum from within data science AI, where they were able to have, well, bigger models, more accurate models, and it was a huge leap forward in the performance of those models. We have that similar trend now within NLP. So, for example, where word2vec falls short is really simple. You can bundle words, you can do calculations with them, but a word is still the same word no matter what the context is. So a bank, if I take, for example, a more Dutch example, a bank can be a financial institution, but it's also a couch. And word2vec wouldn't know the difference. Also, we have, obviously, if we make sentences or have pieces of text, we have long-term dependencies, as we call them. Basically, we start with a name, and then later on, we refer to, if it's, I don't know, Peter, for example, later on, it gets referred to as he. But we all know that he refers to Peter. That's something we can extract from the text. That is something word2vec cannot do, and we're now at the moment that we can basically solve that problem. We now have algorithms that can incorporate memory, incorporate timestamps, and find out things that happen over time in the sentence. So that's really cool. And the latest part of that is the transformer, which is also part of the BERT model, for example. Cool thing is about the transformer is basically something we have seen in translation. For example, the Google Translate stuff, you input a text and another text comes in. So an English text is being put in, a French text rolls out. I find that pretty amazing that we can just do that. In the NLP or data science terms, it's called an encoder and a decoder. So the decoder is basically the thing that decodes the English thing to a French one, and that is part of the transformer stuff. Guys, can you do the additional part? So how it solves that, and don't feel bad if you don't know what's happening down below. I'll explain in a bit. It's not going to go that deep. So the cool thing is that next to context, what basically happens in those networks is you input all the text and you try to predict the next word in a sentence. And what it does, instead of doing it sentence per sentence or word per word, it just inputs the entire text that gets encoded. And a certain percentage, from the top of my head, 15%, is being masked. That's why you see the mask. Input it in BERT, for example, and then it predicts that word. So given the two words, this is, and the other side of the sentence, so it basically reads from left to right and right to left, or the other way around if the camera slipped. And then it just predicts the word you're looking for. What is really cool is that we're at the level that the words being predicted are all accurate. So all the words being predicted are meaningful in the sentence. And that is the big breakthrough we're having. What you see down below is nothing too fancy. It's basically the architecture. What I'm trying to say is that BERT, as you see on the left side, is it reads from left to right. So it incorporates the beginning of a sentence and the end, and then merges that together. Elmo uses a really different architecture. It goes all the way, but also incorporates left to right, but on a different manner. And the OpenAI, so remember the Elon Musk founded one, just does left to right. So that's basically the difference. They all incorporate transformers. Elmo uses LSTM, which is a predecessor of a transformer, for example. But it all incorporates time, does predictions, and tries to encode language and etc. So state of the art.
Okay, so this makes it a lot easier to incorporate contextual information in the NLP models.
Yes.
Would be my condensation. So I read something about a model almost passing the Turing test for producing text.
Yes.
Could you tell us something about that?
Definitely. So I can imagine that, well, for those that don't know what the Turing test is, it's actually, you have, in this example, you have an AI, a human being, and they both have to answer questions. And then the third person or second person, if you don't count the AI, has to find out which of those two is giving the real human answers. So, well, before we dive into the language generation, another important part of how that is achieved is what you see here. So I talked about the transformer stuff and the state of the art. This is the more advanced method of showing that. So instead of you guys having to look at a network architecture, you can actually see what's going on within the algorithm. So you see the text being typed, and what we see here, the highlights in between, are pretty much understandable for us. I mean, if we would go over this piece of text, we would probably come up with a similar highlighted piece of text, which we would possibly use for a summary. The cool thing is, the algorithm figures this out by itself. So it makes a representation of this piece of text it sees, and then it starts calculating the probability. So I have this word, what is the chance that this other word follows it, and how important is this in the grand total of schemes, actually. So this is really cool. That's why we're basically able to do question and answering. So if you have a piece of text, for example, I don't know, when was Napoleon born? Instead of scrolling through the entire thing, you could also Google it, of course. But for example, Wikipedia, if you pose that question, then if you have Wikipedia text, the algorithm will supply you with the answer. And that is basically based on this. So the cool thing is about this, that's why I put the headline in as well, attention is all you need. So this is called attention. And what we're seeing here is self-attention. So the algorithm figures out by itself what to look for in a piece of text, which I find pretty amazing. And it's also really similar how we use stuff, right? I mean, we use attention, we skip through a text, we use attention, our eyes go from left to right, top to down to figure out where the important parts in the text are. And so this is basically a human-like approach. Okay. And really good. All right.
Cool.
Well, on to the generation, where it gets interesting as well. And
yeah, so this is really moving into the future, I think. And so I think that's also an interesting topic. What's going on in research at the moment? What trends do you see? Where do you think the development of NLP is heading, and how does it translate to business application? Well, I just asked 5 questions, but I hope that you can answer them for us.
Yes. We'll go through them one by one, sort of. So This is really recent, May this year. So what you guys are looking at is the first paragraph is something input by a human. And actually, a small disclaimer, the text you're viewing is the GPT-2 model. Number 3 has been released in May, but the text you're viewing is the second model, because they haven't released anything like this yet. But it's, in terms of the data it's been trained on, it's completely similar. And this is the next phase we're moving in. Next to trying to understand text, we're also trying to create text. So maybe we're going to get to the point that nobody else has to write their own Christmas cards anymore. We can just output them like this. You just put a name and then, I don't know, a seed word or the poems for any holiday. So the cool thing is, if you just skim through this, it is grammatically correct. There is not a single word that is in a weird place. But if you go through it more deeply, you will find that by itself, the text doesn't mean anything. So, for example, let me take the first part. We're talking about a unicorn, and nobody has said anything beforehand about a four-horned silver-white thing. So it just sort of deducts that and creates this in this manner. So that's really interesting that we're already getting pretty far. The downside is, in general, it doesn't mean that much yet. So we're getting there. The other downside is it's really expensive. The GPT-3 model was approximately 10 million to train. So that, for me, that's also mind-boggling. Like, okay, what happens if you make a mistake in the meantime? But that's a ton of money, and that's not something any company can do. So, well, I'll answer that in a bit as well. So how does GPT-2.3 achieve this? So, Thijs, if you could do the second part. Yes. So this is the nitty-gritty thing that sets the newest model apart from the latest model, and this is sort of the future as well, aside from the other things I was talking about. Cool thing here is there's a couple of techniques which are really easy to understand: zero shot, one shot, few shot. It's basically, I give you a task, a language task, translate this for me without an example, zero shot. Funny thing is, if you, for example, would give me this, translate English to Chinese, I wouldn't know how to figure that out because I don't have any language model in me. I don't have any knowledge of the grammar, for example. So the model has that, but then still being able to perform this is really good. Now, the difference between one shot, few shot is number of examples, pretty decent. I would love to see somebody in real life be able to do this as well. I mean, my French is pretty absent after high school. So if you would give me a few shots and then ask me to translate an entire English sentence to French, it's not going to happen. So that's the cool thing about this. All right, next slide, please. Then we can dive into the future question. So I've talked about BERT really quickly, GPT-2, GPT-3. You're going to see a ton of stuff. Roberta is an improved one of BERT made by Facebook. There's actually a French one, it's called Camembert, which I find funny. And what you can derive from this is that it's going up in parameters. So a neural network needs parameters to be able to perform the task. More parameters equals better performance in this case, not in general, but in this case. And it definitely equals more money. So right here, we're talking about a couple of 100 billion, I think 375 billion parameters for GPT. And they're actually talking now about trillions of parameters to see how far we can go with this. The thing we're missing is a machine that, as the quote says, can learn from experience. The other thing we're missing, which I think is really important, is that we're just going bigger, bigger, and bigger. And that basically means that research is being left behind. So if you're in academia, you don't have 10 million lying around to train a model, especially if you mess up, then you're even further from home in that sense. So this is basically for the big companies, the Googles, the open AI ones in this case as well. So I'd like to refer to this as the Silicon Valley boys or the cowboys, whatever you want to call it. It's really cool. Luckily, I also view the future in a really bright perspective because a ton of those companies are actually making this open source. So you don't need the gigantic GPU powers. You don't need to spend 10 million on owning a model or using it. There's been a lot of work done on creating smaller models, for example. So, for example, within BERT, you have big BERT, sort of medium-sized BERT, and small BERT. And the difference is only a couple of percent in accuracy. Basically meaning if you have a business problem that doesn't require 98% accuracy, which is the case in almost every project, you could definitely use a small BERT, which could run on my laptop here. So
yep.
I believe
and you
that
don't need
future...
a trillion of parameters.
Exactly. And it's all embedded in. So BERT uses a couple of the 150, I believe, million from the top of my head. That's all in that model. So you just download the model and you use it. And the cool thing about this is it is not task specific. So for example, if you want to do sentiment analysis, you download BERT, you put a sentiment analysis thingy at the end, you have a sentiment analysis algorithm with the power of the BERT parameters being all present. So I hope that the future is moving more and more towards that. Luckily, in the majority of cases, it is. And I hope that more research is being done on this as well, because in the end, the thing that we can use is the open source.
Yeah, it sounds good, and it sounds like there's still a lot more in store in future for NLP. Also, I think well, at least I love four-horned silver unicorns, but also I'm curious to know what we already do at Sogeti with our customers with NLP. How do we apply it with our clients?
Yes. Well, we have something for that. So we have teamed up with a smaller company called Nova One, and that is what you're seeing here. We made a sort of proof of concept for the NS, the National Railway Services of the Netherlands. And this is a BERT model in action, for example. Cool thing is, so the backbone of this is a knowledge base of a customer service center. And what people actually want to achieve in this is that the customer service employee doesn't necessarily have to have experience within the domain. So basically, if you're having your first day at the customer service center, or if it's your 5th year, you have to be able to use their knowledge bank. And by doing so, you have to be able to put in natural language questions. So any question any of us would pose. So for example, what we see here, I will freely translate that. The question is, when does the Thalys go or depart? And then it gives us a couple of answers. So we have the general page of the Thalys, we have a page for how to book a ticket, and the best solution that the algorithm or BERT in this sense finds is on the right side and highlighted. So instead of using the mannerisms that basically connect to a knowledge bank, which normally is the case, you have to have experience with choosing the right nouns, using the right words, the right queries for your search, etc., which you don't know within the first couple of days of working. This allows you to just input a sentence, even up to, for example, I want to go to Paris, take the Thalys, I want to take my dog on a bike. Now, that's a pretty big question. That is going to be answered by using a BERT model on the backside, which we're using here. What it then will do is highlight the important parts of all the text. So next to getting the right result, cool thing is the document you're being viewed, if it's 2 pages or 500 pages, you will get the highlighted best part, which will save you a ton of time. So,
and also I think it will save them a ton of time in maintaining the knowledge in the knowledge base, right? Because you don't have to put in specific terms or search terms or tag it, or you can just add natural text and it will find it.
Yeah, and even the tagging can be solved by using NLP. So yeah, basically the only thing a human needs to do is write the right content, put that in the knowledge base, and then let us or the NLP part do the rest. That's basically it.
Cool.
Yeah, really fun to do. We have another one. That's something I've been working on for the past year at Rijkswaterstaat, which is the ministry for anything that is connected to infrastructure and water management within the Netherlands. And that sounds big. It is pretty big, but luckily this is a smaller project. What you're viewing here is a general view of the dashboard, which I was allowed to view. The backbone of this is pretty simple. So that's the other point I want to make, next to that you don't always need to have the state-of-the-art accuracy or models. So we've seen the BERT model in the previous one. This actually uses word2vec. So what do? We take in text or complaints from any citizen. So for example, they want to broaden or widen the highway. There is a new airport being built, which the people living around that piece of land are not liking, obviously. They can put in a complaint, file a complaint, and then it comes into our NLP pipeline. Basically what we do, we classify the documents not only as being part of, for example, an airport being built, but we also neatly tie that in with, for example, pollution, flight route, etc. So anybody who's on that project can easily see what the text is about and then formulate the right question. So the business case in this sense was pretty easy. They had a team of 5 people, which were actually reading through tens of thousands of documents manually. They were tagging them and then formulating an answer, and they had 6 weeks to do that, which they never made. The 6 weeks were never met. So by using this tool, they can actually meet that requirement of providing an answer within 6 weeks. So nothing else gets a delay. So for example, the construction work, if that gets delayed, that's gonna sort of snowball in terms of money. Also, the Dutch are really keen on using a template, for example, or provide a list of signatures with all people that are basically against something happening in the country.
It's our folder model.
Exactly. Yeah,
yes.
We love using that, and that's been really prevalent in this as well. But they couldn't figure that out. So, for example, they had a pile of documents. They were reading through it, and for example, person 1 and 3 could be reading exactly the same documents. So we also build in a similarity score, filtering out similar documents and putting them in one big pile, so they could just formulate one answer and, for example, answer 500 to 1,000 documents in one go.
Okay.
So really cost effective, time effective, and yeah, they made a ton of savings.
I think both the NS and the Rijkswaterstaat cases are very clear, and there's very clear business cases for them. So that's great examples. So thanks a lot, Paul, for this interview. And before we move to the Q&A, we have 2 more Mentimeter questions. So our audience can go back to menti.com. Here's our leaderboard, by the way. The code is on the screen again, 241715. And the first question is about what you learned today in this webinar. Is it nothing? Is it what transformers are? Or maybe a new meaning of what transformers are? How NLP works and how NLP can be used in a business context. So it will be interesting to see. Well, some people learned about transformers.
It's good.
But I think the majority is in the bottom 2 answers.
Yep.
And I think
hope the people that actually didn't learn anything had a good cup of coffee during this time.
And a nice break, maybe, because all this working from home, you need a nice break sometimes. And well, at least 2% had that. But I think, well, we discussed both how NLP works and how it can be applied in a business context. And that's, I think, interesting sometimes for different audiences. So that's really good to see. We have another question that will turn into a word cloud. I don't know if Thijs is ready to move to the next one. How can you use today's information? That would be really interesting for me and for Paul also to know. And this is a free field that you can fill, and it will turn into a word cloud. So I'm curious to see what will appear.
It's going to be exciting. Ooh.
Improving skill set. That's cool.
That's good.
Sales at client sites, cool as well. Can they call you, Paul, if they have a client who wants to discuss?
Definitely.
Great. Future research. Money.
It's always good in the COVID times.
Yeah, of course. Innovation, I see Thinkubator. We can definitely approach this with the Thinkubator, I believe. Yeah. Because there will be clients wondering how best to apply NLP in my business context and looking for the right use case. And I think Thinkubator could be a good process to approach it.
Yeah.
OCR.
Yeah. Optical character recognition. Basically, if you have a receipt, you can use your phone nowadays to scan the receipt, and then it takes out all the stuff it sees. So that's basically image recognition combined with NLP. Also cool. Yeah.
Is the cloud still building, Thijs, or are we? It seems we're quite there. Oh, something coming up.
Whoa.
Wow. Reflect, more sales, client conversation.
It's a ton of stuff coming in.
Yeah, that's really good.
I'll need a bigger screen.
Improving product with an upcoming chatbot, more business value. It's a lot of positive terms. That's at least my analysis.
Also like the sort of hidden Star Wars word floating around.
Oh, I didn't see it. What did you see?
Yeah, the C-3PO. I imagine that was the idea of it. Judging by the Star Wars Lego being behind me. Cool. Yeah, I think we have a pretty decent insight.
Yeah, that's really cool.
Yeah.
It's great to get feedback this way, even when you cannot see your own audience. I see that we have some questions in the chat as well.
Oh yay. Okay.
Let's see if I can see them. Deepika or Margot, could you help us with the questions in the chat?
Yes, Yolene.
That'd be great.
Right. So we have the first query. Just a moment. Yeah. So the first one is from Mikhail, who asked, what is the status of simultaneous translation of spoken text? When will it be 99% perfect?
I'm not sure if we're ever going to achieve that. So the speech to text is, I'm more focused on the written parts of text. I haven't done that much with speech to text. But I know there's, well, the state of the art is already pretty good. But I'm not too sure what the state of the art accuracy in the models is. If I judge simply from what Siri can do, it's already pretty okay. What I do know, for example, is that if you compare the Google to the Siri one, is that they parse the language completely different. So, for example, the Google one takes it step by step, so syntactically parsing it, and they might have made improvements on that already. And Siri back in the day used the entire sentence by itself, basically delivering different answers as well. So that's the stuff I've been exposed to. Other than that state of the art, I will have to look that up. If you want to know more about that, I can dive into it and send me an email and we'll chat about it. Yeah, definitely interesting.
Sure. Thanks, Paul. So the next one is from Manupam, who says, are word to vec sequence to sequence same?
In a sense, no. If you take it into the neural net kind of way it works, it's basically for, let me see how I can phrase this correctly. Yeah, so if you've ever seen a linear regression, going way back to high school, because I have to keep in mind the general audience, that is basically a linear problem what we make. So for anybody who has seen anything on deep learning, you always see the neural networks with all the little bulbs and then connected and basically mimicking how our brain works. Word2Vec is nothing more than that. Basically a one layer or a linear linear math problem, for example. So it's basically a one layer neural network, if you'd like to call it like that, phrase it like that. The NLP stuff by itself is still a sequence problem. But if you dive into the sequence to sequence part of it, then you dive into the recurrent neural networks, the LSTMs, the transformers, etc. So next
Do
one.
we have more questions?
Exciting.
I believe not. I think we would have heard Vika.
Otherwise, as I said, if there's more questions, feel free to shoot me an email or plan a digital coffee and we can have a chat about what we can do or dive into some NLP stuff together. Nothing wrong with that.
Okay, great. Then we'll end the webinar here. Thank you all for attending. It's good to see your feedback, and I hope we can continue it from here and bring the topic further for Sogeti as well.
Cool. Thanks, Jolene, and thanks everybody for
Thank you, Paul.
watching and the Mentimeter stuff. Awesome.